Let's talk a little bit about innovation types. There's a tremendous amount of thinking available on innovation. In business, innovation results in changes to customer segments served or changes to other business model elements. There are four well-defined types of innovation. There are two strategic moves between different innovation types, pivoting and shifting. No change is known as sticking. And here's an illustration of the types and innovation moves. Incremental innovation sees normal small changes in existing customer segments or minimal changes in other business model elements. Such a standard service or product improvement is a stick strategy. A good example of this is the minor operating systems patches downloaded overnight in regular computer maintenance. Architectural innovation sees a business addressing an existing value proposition to a new customer segment. It's a pivot strategy, where the business keeps one anchor fixed, pivoting off it. A relevant example here is Nike's initial pivot into golf shoes and clothing. Disruptive innovation sees substantial changes in the business model's elements other than the customer segments served. It's another pivot strategy. Again, Nike offers a great example with its recent offering of self-lacing shoes. Radical innovation sees a business serving one or more new customer segments and substantially changing its business model elements. It's a switch strategy, where the business model changes holistically. In this case, Nike radically shifted when it moved into manufacturing golf clubs and balls. Conventionally, there are two main processes that lead to innovation. Incremental innovation, the stick strategy, broadly follows the plan, do, check, act, PDCA, or Deming cycle. The cycle is an iterative four-step management method used in business for the control and continuous improvement of processes and products. Step 1, plan. Establish objectives and processes required to deliver the desired results. Step 2, do. Carry out the objectives from the previous step. Step 3, check. Evaluate the data and results gathered from the do. Compare data to the expected outcomes to identify similarities and differences. Evaluate the testing process to see if there are changes from the original test created during the planning phase. Place the data in a chart to more easily detect trends as the PDCA cycle repeats. Charting the data helps identify which changes work better than others and if the changes can be improved. Check is also known as observing, signaling an intent to examine the service or production processes more deeply. Act is where a process is improved. Records from the do and checked phases help identify issues with the process. These issues may include problems, non-conformities, opportunities for improvement, inefficiencies, and other issues resulting in less than optimal outcomes. Investigate, find, and eliminate the root cause of issues by modifying the process and re-evaluate risk. At the end of this phase's actions, the process has better instructions, standards, or goals. Planning for the next cycle can proceed with a better baseline. Work in the next do phase should not create a recurrence of the identified issues, otherwise the action was insufficient. The adoption of standards guides initial changes in services or products to meet standards. As the standards evolve, further changes consolidate improvements. Conventional, architectural, disruptive, and radical innovation processes follow the broad structure of the process first established in 1962 by Rogers. Architectural, disruptive, or radical innovations are responses to opportunities, needs, or challenges. There are 7 principal sources of opportunities, needs, or challenges: unexpected occurrences, incongruities, process needs, industry or market changes, demographic changes, changes in perception, and new knowledge. Most innovative business ideas come from methodically analyzing each of these areas of opportunity, some of which lie within particular companies or industries and others in broader social or demographic trends. Astute leaders ensure that their organizations maintain a clear focus on all 7. Nevertheless, analysis can take leaders only so far. Once they've identified an attractive opportunity, they still need a leap of imagination to arrive at the right response. Call it functional inspiration, also known as when the magic happens. As for the occasional flash of creative genius, these are outliers. They're a form of new knowledge. Don't be deceived by the word genius, by the way. It's in most of us, and we just need the right encouragement to bring it out. Pure research might be a source of innovation. Whatever the source, executing further pure and certainly applied research usually deepens understanding of the opportunity, need, or challenge at hand. Pure research is original investigations for the advancement of scientific knowledge. There's no specific objective of applying this knowledge to practical problems. Applied research consists of scientific investigations intended to solve practical problems. As will be covered later in the course, bear in mind that not all research is done in laboratories by people in white coats. Science extends beyond technology, engineering, and mathematics into politics, economics, society, technology, and the natural environment. Development is closely allied to and often intertwined with research in the guise of R&D, although it conventionally follows research. Development is the process of putting a new idea in a form expected to meet the needs of an audience that will potentially adopt the innovation. Commercialization is the production, manufacturing, packaging, marketing, and distribution of a product or service that embodies innovation. Commercialization is converting an idea from any source of innovation into a product or service for sale in the marketplace. Prototyping spans research, development, and commercialization. The main objective of prototyping is to answer questions related to building the product or service. Can it be built? Will it work as expected? How cheaply can it be built? How fast can it be made? Prototyping is typically a process of incremental product or service development, not dissimilar to the Deming cycle outlined previously. Innovation, diffusion, and adoption are the processes through which an innovation goes out into the world. Diffusion occurs through a variety of channels. The diffusion process offers an innovation as a value proposition to various customer segments managed through customer relationships. Relationship management, effectively gatekeeping, governs the scale and rate of adoption constrained by the diffusion process. Finally, the consequences of an innovation process are the changes that occur in individuals and political, economic, social, technological, or natural systems due to the adoption or rejection of an innovation. Let's take a look at Prio Typing, which is an unconventional innovation process. Prio Typing starts from the same sources as a conventional innovation process. An opportunity, need, or challenge is identified. However, at this point, the subsequent sub-process of research, development, commercialization, and diffusion and adoption collapse alongside each other, occurring in parallel, as we can see here. Here's an example. On the left is a prototype of the Palm Pilot next to the final product. Jeff Hawkins, the founder of Palm Computing, mocked up a Palm Pilot with wood and paper. Then, pretending it was a working device, he carried it with him for several weeks. His objective was to learn if he could use such a device or would use such a device before going to the expensive and time-consuming step of building a working prototype. Hawkins' prototype simulated the core experience of having and using a Palm Pilot. As noted previously, prototyping's main objective is to answer questions related to building the product or service. Can it be built? Will it work as expected? How cheaply can it be built? How fast can it be made? In contrast, the main objective of prototyping is to answer questions about the product's appeal and usage. Are people interested in it? Will they use it as expected? Will they continue to use it? Here's an illustration of the Palm prototype, and product side by side. Notice the dramatic difference between prototypes and prototypes. Severe explains the prototyping process thus. Step 1, isolate the key assumption. What's the one assumption about the idea that if false means it's definitely not the right it, which is Sevilla's term for a prospective innovation? Step 2, choose a type of prototype. You can take a look at different types of Prio type in the attachment, which is in a file on this page. What type of prototype will isolate and test the key assumption? Step 3, make a market engagement hypothesis. How many and what kind of people will do what with the prototype? The hypothesis can be as simple as X% of Y will do Z. A solid hypothesis takes the guesswork and opinion out of testing. Step 4, test the prototype. Now put the prototype into the real world and see how people interact with it. Start small, one place, one time. Step 5 is learn, refine, and hyperzoom. Evaluate the results, refine the prototype with the new data. If the hypothesis held, decide what other situations to test the prototype in to get a complete picture. This is hyperzooming. As a clear picture emerges, the next step is physical prototyping. However, the research, development, commercialization, and diffusion and adoption processes are much shorter, reducing time to market and raising assurance of product adoption.